I'm Andres Garra, and the project manager and lead designer for land development. Our firm is Intech Design and Engineering, and our project is a public charter school development called Compass Rose Academy for the Port Authority. It is located on the southwest side of San Antonio on what used to be Kelly Air Force Base. The Port Authority is a workforce development organization that is focused on the future of kids and families in the surrounding area. The site is currently platted under the Port Authority's Master Development Plan that has accounted for this kind of development and therefore will not be needing a replat. The MDP defines the zoning of this project as Commercial 3 and will suffice for the school's development. You can see the outline site in both the MDP and current plat of the property. The demoing and redesign of Billy Mitchell Road will be allowed since it has been closed prior to development by the Port Authority. Part of Chennault Circle will also be edited to fit within our site plan. There is a list of utilities that will need to be demoed or capped in coordination with SAWS and CPS.
We will be providing 40 parking spots through a redesign of the parking lot, and also our site is condensed for future developments. Next. Our site has a fire access, and our fire protection plan is designed following all NFPA fire code regulations. We will have one fire hydrant and an NFPA 13 sprinkler system. We have a hose line in our site, and we have designed in accordance to the fire access regulations, which include 25-foot minimum inside turn radius and a 50-foot outside turn radius. Areas indicated as access for aerial apparatus from the fire truck is shown on the elementary school. Next. Our site is relatively flat, and we are using a rational method for our watershed calculations. Our buildings will be elevated 4 to 5 feet, and we will have a fixed floor elevation of 689. This helps maintain grade and drain to the existing elevations, and our design satisfies ADA regulations. Next. This is an image of what the underneath of the building looks like in order to accommodate the foundations design. The structural and geotech team will discuss further. Next. For our stormwater pollution prevention plan, silt fencing, grade inlet protectors, and the stabilized construction entrance will be placed. All flow patterns will be maintained, and our project limit is about 5.12 acres, and the water will run off from the roofs, and the stormwater pipe will collect and release in the direction of the flow path. Next.
I'll be going over the geotechnical and environmental aspect of our project. Next slide. The site geology mostly consists of gravel, sand, silt, and clay, and from the table we can see we're mostly working with strong clay soil. The site condition is grassy with some scattered trees. The vertical potential rises 2 to 3 inches, so with the request of the owner, we'll be doing a suspended slab with drill piers per column. Next slide. For the cafeteria, we'll be having a 20-feet shaft and a diameter of 1.25 feet and a pier capacity of 80 kips. The piers will also be reinforced by 8 number 6 bars, and the bottom of the slab will also be covered by 3 feet crawl space. Next slide. For the school, we'll also be having a 30-feet shaft and a diameter of 3 feet and a pier capacity of 468 kips, and the piers will also be reinforced by 10 number 18 bars. Next slide. For the environmental aspect of our project, our site was previously used as a military base, which triggered a phase 2, and we ran a sulfate test and found that our value was lower than EPA recommended. And with that, that concluded our environmental assessment. Next slide.
I will be going over utilities next. We have existing overhead electric communications and gas line. We also have a 12-inch water main going north of our site and 2 8-inch sanitary sewers coming from the south. We will further contact service providers to connect to these utility lines. Next. For water flow, we will be using a smart meter that reads for domestic and fire. We will be using a 12 by 10 fire flow meter. We'll be using a separate meter for irrigation. Based on our site elevation, we have a pressure of 68, which is less than 80. Therefore, we do not need a pressure reduction valve. Next. For wastewater flow, we'll be using a 6-inch sewer line that fits our flow needs. We are maintaining a 1.06 slope that connects to existing sanitary sewer manhole. Next. These are the proposed sanitary sewer connection. Next.
My name is Paul Telchik, and I'll be covering the design of the elementary school structure. Next slide. The elementary school building is 2 stories, and the floor plan is a total of 40,000 square feet. Next slide. The first floor layout will have 12 classrooms for kindergarten through 2nd grade, as well as specific education accommodations, a library, a computer lab, a lobby, and front offices. There will also be 2 stairwells and an elevator. Next slide. The second floor will consist similarly of 12 classrooms for 3rd through 5th grade, as well as 2 science labs, computer lab, teacher's lounge, and a flex room. Next slide. The steel structure will be comprised of 24 feet, 20 feet, and 10-foot spans. For the roof, the girders will be W12 by 14 beams. And for the second and first floor, the girders will be W18 by 55 beams. The column on the first floor will be W10 by 33 beams, and the columns on the second floor will be W10 by 30 beams. The lateral bracing will be different spans of L8 by 8 by 1.5 inches. Next speaker.
My name is Kevin Cyples. I'll be talking about the cafeteria and event center building. Here's the floor plan. It is 100 by 60 feet, has a fully operating kitchen, a boys and girls restroom, and is constructed out of A992 and A500 grade steel. Next. For the interior roof girders, using factored load, Mohn equation for simply supported beam, unbraced length, and then checking deflection, we chose W12 by 26 members. Here's a 2D view and a 3D view. Next slide. For the interior columns, using factored load, tributary area, effective slenderness ratio, finding a critical stress, we chose W10 by 33 wide flange. Next slide. Here's a inside view of the cafeteria. Next slide. And a 3D view. Next slide.
I'm Edgar Rivera. I'm in charge of traffic design. Next slide. The past background traffic showed a negative growth rate for this area. Because of this, the default 2% rate was used for the traffic impact analysis. Next slide. Weekday AM yielded the highest peak hour trips using the ITE trip generation manual, and trip distribution was influenced by the assumption that most charter school students will not live nearby, and most traffic will arrive and leave using arterial streets. Next slide. The TIA simulation for the present, no build and build out scenarios were done using the Transmodeler SE software. Next slide. The school generated traffic has an acceptable impact on the surrounding road network. The level of service remained the same or improved for the surrounding intersections. Next slide. To keep traffic away from the main road network, a specific route will be deployed for pickup and drop off. It will be enforced by the school and aided by signs, including a no left turn into the school. Next slide.
With that, that concludes